Hey there kids, welcome to another math lesson. This is for grade 5 Eureka Math, module 3, lesson 15 homework. And hopefully you already did it already, and I will just talk you through in case you have any mistakes or misunderstandings about these problems. They can be kind of tough, not as tough as the previous lesson, lesson 14, that's really hard. But the objective at the bottom, solve multi-step word problems, assess reasonableness of solutions, using benchmark numbers. So basically, does my answer make sense? Yes or no? Why or why not? So that would be the time when you think, maybe I made a calculation error. So the directions say to solve the word problems using the RDW strategy, show all your work, read, draw, write, and seriously, show all your work. Don't ever tell me or your teacher, oh, I did all the work in my head. We can't stand that. Honestly, I want to see it all. In fact, I want to see the mistakes. It's very helpful for me to see the mistakes because then I'm like, oh gosh, you're doing this wrong, or you did this step wrong, or here's the error, and then you can easily fix it. So please show all your work, always. All right, let's get into it. A baker buys a 5-pound bag of sugar. She uses 1 2/3 pounds to make some muffins and 2 3/4 pounds to make a cake. How much sugar does she have left? This is such a classic question. You will see this on so many tests, stuff like this. Not exactly this, but we've got a total, we have parts, and then we have something left over. This is a classic 5th grade question. So get good at making your tape diagrams and label them carefully. First of all, we have 1 2/3 pounds to make muffins, 1 2/3 for the muffins. And again, like, it doesn't have to be exactly 1 2/3 size out of 5. We're just making pieces. Then she made 2 3/4 pounds or used it to make a cake. So we've got cake, 2 3/4. There is something left, and we don't know what it is, okay? And so that is your tape diagram, and then the tape diagram can help you see, I need to add these up or do repeated subtraction. It's up to you, the strategy you use, but I've told you guys before in other videos, I like to add up the total that's going to be taken away and do one subtraction step. So 1 2/3 plus 2 3/4. We need common denominators. You should know that by now. You can, at any point in this problem, add your whole numbers. Okay, you can wait till later if you want to do that because basically I'm just separating my fractions from my whole numbers. So 1 plus 2 is 3, yay. Move right along, get your 12 as a common denominator. And then since the other number is the scale factor, it helps getting your numerators. 4 times 2 is 8, and 3 times 3 is 9. Now I have my 3, but I also have a large number here on top, which means that's improper. So this is a mixed number all by itself. So 17/12 is 1, and then the difference between these two numbers, that's 5, and 12 is your label. Put that all together, and you get 4 5/12 as the total amount of pounds used that we know about. Okay, now again, go back up and see, well, what did I just find out? I found out the muffins and cakes, pounds of flour used. That does not give me the answer here. So this is multi-step word problems. Now we're going to take our 5 pounds and remove the 4 5/12 pounds that were used. That's our second step, and this can be a 2-step process. 5 minus 4 is 1, but you still have to take away because subtraction is continually moving down the number line in a negative direction. So we don't add that on, we subtract it away. When you do this method, remember you're going to go down below this whole number, which is 0. You don't have to write the 0, you just have to complete the whole. The whole is 7/12, and that would be pounds left of sugar. And that's your answer right there. Okay? Next one. Oh, this one's fun. Okay, they love to throw in these crazy things. This is really good to kind of keep your brain thinking. A boxer needs to lose 3.5 kilograms in a month to be able to compete as a flyweight. In 3 weeks, he lowers his weight from, here we have some decimals, 55 and 5/10 kilograms to 53 and 8/10 kilograms. How many kilograms must the boxer lose in the final week to be able to compete as a flyweight? So you have a couple things going on here, and a lot of kids will be a little bit confused about what do I do with these decimals and what about the fraction? Why are they in the same problem? Well, that's just life. So what we have is we have the total of 3.5 kilograms, and then we have given numbers. Now, we have worked with decimals before. It's just been a while. So he's already lost some weight. Now, this is a very simple part of the problem. We have the weight that he started at and the weight that he is now. And we need to find the difference because he's already lost some of the 3.5 kilograms that he has to lose. Okay, so he has lost some, and he still has to lose some more. So let's figure out what he has already lost. So it's really simple. Just remember about your borrowing. So take 1 and give 10. Every place value position that is to the left is 10 times greater than the ones to the right. So that's why I can go here and say take 1 of the ones and give 10 of those to the 10th place, and then find the difference between 8 and 15, and then that's 7. Decimal down. Again, the process you don't want to forget, line up by the decimals. Do your subtraction. 4 minus 3, there's your 1. Now that's 1. Kids are going to say, it's 1.7. Okay, don't say point. It's 1 and 7/10. Now, the key here is that if you turn that into 1 and 7/10 as a fraction or mixed number, now you're getting back to what we've been doing so far. Okay? And so once you have this, you can take your 1 and 7/10 and take it away from the 3.5 to find out what he still needs to lose. So label this lost so far, and label this one still needs to lose. And now we've got our tape diagram with our pieces. So take your 3.5 and subtract 1 and 7/10. And this one you can do in a couple different ways. When you have 1/2, you can simply change this to 5/10 right away if you want to do it that way. But you're still going to end up with a larger numerator over here on this side. So at this point, you can do 3 minus 1 and 7/10 all by itself. The 3 minus 1 giving you 2, but then you still have to take away the 7/10, and then we have to put that back. So 2 minus 7/10 is 1 and 3/10, and we still have to consider the 5/10. And that is what he needs to still lose. And so you could say still needs to lose 1 and 8/10 kilograms, or you could say 1 and 8/10 kilograms. So you've got some options because we've got decimals that actually work with tenths and hundredths and thousandths if needed. But this one would be fine as a decimal or a mixed number. Okay. A construction company. We'll focus. A construction company builds a new rail line from town A to town B. They complete 1 1/4 miles in their first week of work, 1 2/3 miles in their second week. If they still have 25 3/4 miles left, that's a lot. What is the distance from town A to town B? Now, again, you can create your tape diagram. You can say, here's town A and here's town B. We've got our week 1 and week 2, and we know there's a huge section here that would represent that the rest, okay? And so you've got your 2 different amounts. First week was 1 1/4. Second week is 1 2/3. And the question is saying, what is the distance? Now, we're looking for the whole, and this is just going to be putting all these pieces together. 1 1/4, 1 2/3, 25 3/4 will make the distance. Now, the strategizing, okay? We did this in a couple lessons ago, and it was like, hey, if you've got something with the common denominator and it's just addition, we can use the commutative property, move things around, and combine like terms. So let's do that here. We've got 25. I'm going to only combine these. If you want to rewrite it, you can. Sometimes that's easier for students to see what we're working with, and then move that 1 2/3 and do it last, because these have fourths. So 25 plus 1 is 26, and guess what? 3 plus 1 is 4, and that's going to be 1 whole. So 26 plus 1, 27. And then I have that 1 2/3, and now it doesn't matter what the denominator is. And your final answer was really easy to get. 28 2/3 miles is the total distance. Between the 2 towns, or town A and B. Towns A and B. I'm always trying to make it shorter. Yes, you should always write a nice answer. Okay, next one, a catering company. Again, with the decimals and the mixed numbers. So think about what we did on the last one. Think about how many decimal places we are to the right. Think about the possibility of making a fraction with that while I'm reading it. A catering company needs 8 7/5 pounds of shrimp for a small party. They buy 3 2/3 pounds of jumbo shrimp, 2 5/8 pounds of medium-sized shrimp, and some mini shrimp. How many pounds of mini shrimp do they buy? So we have the total. And what if you wanted to see that in a fraction? What would it be? And we haven't had a lot of experience with the decimals yet, but as we're getting to lesson 15 and lesson 16, getting ready to start working on decimals, this is 8 and a decimal fraction, 75/100. Just read it correctly and write it, and that is your total pounds. And then we've got the 3 2/3, which is the jumbo, and we've got 2 5/8, which is the medium, and we have question mark mini. Okay, so label everything. Please make a tape diagram. Take the time to do it. It will help you understand the part to whole. Same thing we did on the other one where we knew parts, but we didn't know a section, and we do know the whole. It's a combination of steps. Add up what you can. Get a common denominator. Add the whole numbers at any point you would like. 24 is the common denominator. You can use your skip counting method if you want. Remember, line them up. Skip count until you see a number that they have in common, and so on. Okay, so 24 is my common denominator, and this other number is my scale factor. So to get from 3 to 24, use 8, and then multiply 8 times 2 to get 16. To get from 8 to 24, it's using 3 as my scale factor. So 3 times 5 is 15. Add up 16 and 15, and you get 31. And this right here is an improper fraction with a value of more than 1. So we're going to combine the 5 with 24 24ths plus the difference between 31 and 24, which is 7. And that is going to be 6 7/24. That is the total of the jumbo and medium shrimps together. So that's only part of the problem. Now we need to take our total, which is 8 7/75. Now that's kind of a big denominator. So I'd really like to use something simpler. Can I simplify that fraction before I do my subtraction? Yes, I can. Think about a common denominator or a common factor that I could divide into both of these. A common divisor is another way of saying it. I could divide by 25/25, which is a value of 1, so I'm not changing the value of this, and I could end up with 8 3/4, which is a whole lot easier than using 8 7/75. So now I have my total as 8 3/4, and I can subtract the 6 7/24. Now, think about it before you start. We have a couple different ways we can do this, but I want to use this method that I don't always use because this fraction is bigger than this one. So all I'm going to do is I'm going to change this fraction to have 24ths. So I'm going to leave the 8 for a second. Leave this totally alone. Okay, instead of taking 8 minus 6 7/24. You can do that. Remember, we have lots of tools to do this subtraction problem. But I'm going to take my my denominator and say, okay, how did I get from 4 to 24? What's my scale factor? It's 6. 6 times 3 is 18. You guys might be saying, why are you doing this, Miss Dennis? It's because when I look at the size of this fraction, I know I'm going to have a nice big numerator to subtract the 7. And if I do it the other way, it actually takes a few more steps. This one, today, on this problem, is actually easier to do this way. So 8 minus 6 is 2, and then 18 minus 7 is 11, and then we have our 24ths, which is our label, and it's pounds. And that is the fastest and easiest way to get that. But if you get 2 and 11 24ths pounds of mini shrimp, then you got your answer. And circle it, and then we'll move on. Okay? All right, and here we are at the last one already. Mark breaks up a 9-hour drive into 3 segments. He drives 2.5 hours before stopping for lunch. After driving some more, he stops for gas. If the second segment of his drive was 1 2/3 hours longer than the first segment, how long did he drive after stopping for gas? And in the next version of this book, they're going to talk about how long did he have to stop to plug in his EV and have lunch before he could get on the road again. Haha. Okay. 9 hours. That is the total amount he has for this trip. It's divided into 3 segments. I don't really care what size they are. Just make 3. He drives 2.5 hours before stopping for lunch. You can even say, look, it's a lunch break. After driving some more, he stops for gas. Look, it's a gas break. And this is the some more. Don't know. And then they say if the second segment, they don't even tell you how much it is, but they do tell you how much longer it is. If the second segment of his drive was 1 2/3 hours longer than the first, how long did he drive after stopping for gas? So don't worry that you have 2 question marks here. What you want to do is you want to set it up in an expression so we'll see all the parts. We have the first segment. When we get the second segment amount, we will figure that out. Then we add that to the third segment, and then we have 9 hours. Okay? Now we do know that this is 2.5, but the second segment, that's what you should be thinking about. I got to use that 1 2/3 hours longer. So the first segment is 2.5, and the second is everything that the first has and 1 2/3 more. So I need to put those together before I can know how much my second segment was. Third segment, we don't know. 9 hours is the total. So if you want to do all 3 together, you can. If you want to combine and get sixths, you can. I can barely say that. Sixths for your common denominator, you can do that too. It's really up to you. Since I'm saying, hey, let's make a second segment out of this so we can label it clearly, although they're not asking us to do that, they just want the total of this third section. Here's how you would get the second section. Make a common denominator. This is my scale factor, which means 3/6 and 4/6. 3 and 7/6, which is 1 and 1/6. 1 and 1/6 plus 3. So that's going to be, I know I write every single thing and you guys probably skip this step. That's fine. That's your second segment. Here's your 2.5. Here's your third mystery section. And now we have our first segment, second segment, and we know those. So now we're going to add up our first and second, which again, some of you may have done these two, and then you can add that third one. Does not matter. We just need a common denominator. 6 works, and you don't have to use 12. I hope you know that. So let's change the halves to sixths. The scale factor is 3. 2 times 3 is 6. Therefore, I have 3 here. And if I have 4 and 1/6 as my add end, then it's going to be 4 and 2 make 6. 3 and 1 makes 4. And now I have 6 and 4/6. I'm not going to worry about simplifying because I'm not to my answer yet. Now I just know, ooh, you probably couldn't see that, but now I have my first and second segments, and I can finally do the subtraction step to find the difference between the parts that I know and the part that I don't know. And see why it doesn't matter that I didn't simplify it here, because I'm going to have to take it away. You can simplify it if you want. Oops. Oh, dear. Super excited about finishing. There it is. Okay, so you can simplify it before. It doesn't matter. You'll have to simplify it at some point. So do the 2-step subtraction. And you can simplify here. Or you can simplify first. And get your same answer here. And so the final way to label this is to say it's this many hours after stopping for gas. Yay, 2 1/3 hours after stopping for gas. Yay, and we're done. So I hope this was helpful. Click subscribe, come back again. We'll see you on the next video. Bye for now.